Hello everyone, welcome to this video on solving LeetCode problems with APL. Today we will be tackling problem number 1431, kids with the greatest number of candies. And this problem, the problem description is as follows. We have an array that tells you how many candies each kid has. And then there's an integer which represents the number of extra candies I can split among the kids, and it asks, well, with that amount of extra candy, is there a possibility to make each kid have the greatest amount of candy? So I'm sure the way I said that was very confusing. So let's just read what says in here. So for each kid, check if there is a way to distribute that amount of extra candy among the kids, such that he or she can have the greatest amount of candy among all of the kids. And notice that multiple kids can have the greatest number of candies. Okay, and this is just a very weird way to phrase the problem, because the operation that we actually need to do is for every single kid. So for every single kid, sum that amount of extra candy and check if that number is greater than the current maximum amount of candy, greater than or equal to the amount of maximum candy existing. And so that's actually very simple to do in APL because of our scalar functions. So let's copy this. So this is our kids vector, and the commas there are irrelevant. So this is our vector 2 3 5 1 3, and the extra candy is 3 in the first example, I think. Yeah, it is. And so what we need to do is we need to compute the maximum amount of candy that the kids have, and now we need to compare this with what? We need to see if this is smaller than or equal to the amount of candy the kids have plus the extra. Because if we take a look at kids plus extra, what this is the amount of candy each kid would get if I gave all of the extra candy to them. And if this is greater than or equal to the current maximum, then that kid gets a 1, which is true in APL. And if the amount of candy that kid has, which is 1 for this kid, plus 3, which is the extra, gives me in this case 4, which is less than 5, then there's no way that I can distribute the extra candy and make that kid over there have 5 or more candy. 5 or more candies. Now I'm confused. Is candy countable or uncountable? Yeah, so this gets a 0 over there because 1 plus 3 is not greater than or equal to 5. So this is our solution. It's a really simple solution. And we can write this in tacit form. So if you like point-free solutions, and in my opinion these are the most elegant solutions, so the way we do this is, well, let's take the maximum over or atop the right one, so we want the maximum atop the kids, and then this should be less than or equal to the addition of the two terms. So the way this solution works is you give it the extra on the left, the solution, and then the kids. Yeah, and I got this right because I'm not very good with tacit functions, so maybe I screwed this up, but no, I didn't. And what I'm doing with this tacit function is extracting a pattern from over there. So a tacit function, so basically I wrote my tacit function with 3 functions, and these 3 functions, when they are used diadonically, this reduces to a specific pattern, which is the left argument, the right argument, the left argument, the right argument. So let's put this inside a different tool so that it makes more sense. So this is comparable to the FGH tacit solution. So what's happening is both arguments go to the left tine of the fork. So this is a fork. Both arguments go to the right tine of the fork, and then these results go to the middle function. and so I'm doing the correspondence I'm finding here is this G is the greater than, sorry, the lesser than or equal to, the H is the plus, and the F is the maximum. So this is a max reduction, so this gives me the maximum in a vector. Now the problem is this maximum reduction should only be applied to omega. We don't care about the extra here. So what I'm doing is I'm using this atop right tag. So this is that. I'm doing more or less this, and when I do this, this is the same as f omega. So this is what I'm doing here, and this is my tested solution. If you prefer a different, and that's perfectly fine. So if you prefer a different, what we want to do is the maximum reduction, and then less than or equal to alpha plus omega. And this is our solution. So the solution with the different, there's the extra on the left and the kids on the right. And let's also test it with this second test case. So the extra here was 1, and the solution is that, so 1 0 0 0, true, false, 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 so that's fine. Also with the different, and our final test case is 12 1 12 with 10 extra candies. So 12 1 12, so true, false, true, and then also with the different. So that's it, a very simple solution to this LeetCode problem. So if you come up with anything else which might be shorter, faster, or even simpler to understand, please feel free to leave it in the comments down below, or actually maybe make a pull request to the GitHub where I'm hosting all of these solutions. So it would actually be a lot of fun if we were able to gather plenty of different solutions. So feel free to do that. And otherwise, I will see you in the next video. Bye.